Yeah, that's a weird smell. That's definitely not chloroform or acetone. It's not what we started with.
Oh yeah.
That's something else.
Super cool.
Before we can start any actual chemistry, we need to make sure our bleach is cooled to 0 degrees Celsius. So I'm going to do that first in a fridge.
Push the bleach in the fridge.
At this point, I very much fucked up. I left it in the fridge way too long, and it was completely solid. So I had to spend a couple hours thawing it out before I can move on to the next step. Don't do what I did. Once our bleach has been cooled to around 0 degrees Celsius and it's, a liquid, we're going to place it into an ice bath. This isn't super necessary. I'm doing it out of an overabundance of caution. But this reaction is supposed to be pretty exothermic. I actually didn't have too much of a temperature rise when I added my acetone, but I still did the ice bath just in case. And I recommend doing it as well, especially if it's your first time. Now everything's pretty much ready. Off camera I measured out 67 milliliters of Dollar Tree acetone into a graduated cylinder, and I'm just going to add that to our bleach jug, shake it up to ensure it's all mixed, and once that's done, we're going to remove the cap to give space for any vapors or anything to vent, and I will add the thermometer occasionally to check the temperature. I actually looped an inoculating loop through it so that the thermometer doesn't fall in to the container. I don't know, I thought that was kind of nifty. But there, I have it sitting there, so I can monitor the temperature, and I just check this every few minutes or so, make sure it doesn't go higher than like 20 degrees Celsius, because then you get into the dangerous zone where acetone and chloroform can start flash boiling if it goes any higher than that. But I left it here for a while, and it was chilling. We let our solution sit and do its thing. I'm going to interrupt this with a quick joke session with Mr. B. Enjoy.
Mr. B, I have a chemistry joke.
Oh yeah.
Two chemists walk into a bar. The first chemist orders H2O. The second chemist says, "I'll have a glass of H2O too." The second chemist promptly dies.
Second guy shouldn't be a chemist.
Coming back to our solution, 2 hours and 45 minutes later, or around the time the reaction should have completed, we can see that the bleach is now around room temperature and not too much seems to be happening. So I'm going to go ahead and stop this and start decanting off the upper aqueous layer. Now, I've done this a few times off camera, and every time, the upper aqueous layer still comes out slightly cloudy, whether I wait 3 hours, 5 hours, or 2 days. And I know that usually means it's not done reacting, but I don't think that's the case in our case. I have gotten very bad yields though, and I have my theories about that. I'll get into that more later. But the base thing here is decant off the first couple top layers into 1 liter beakers and save the last 200 to 300 milliliters to be added to a separatory funnel. That is how you'll get out your immiscible chloroform separated from the aqueous layers of sodium hypochlorite, sodium chloride, sodium hydroxide, and whatever else is in there. So I'll move on to that now. Something I found pretty cool, but after I poured off the last bit into a beaker, you can see these little immiscible beads at the bottom, and that would be our chloroform. So our yield is pretty measly, but still pretty cool if you look at that. It's kind of trippy to watch. Yay! While this isn't super impressive, I decided to include the shot anyways, but here's me adding it to the separatory funnel. Not a lot starts to happen until we get to the very bottom of the beaker. And as you can see at the end here, I'll replay it again, zoomed in, but you can actually see our little layer of chloroform separate out at the bottom because it's immiscible. Right there, you can see all those beads falling to the bottom. I always think that's cool to look at. But, as you can see, that's a really tiny amount. I calculated our yield even based on a lower percentage of hypochlorite, which I think is possible. I think the manufacturer just lied about the percentage on the bottle. it's only about an 8% yield, so pretty awful. But it's enough that we can see. And I did a few more runs off camera so that we'd have enough material to actually do our lab with. But yeah, I'll move on to that. I couldn't find the clip, but we ended up with exactly 8.2 milliliters of chloroform. So, on to our next step for making chlorobutanol. I first use an Erlenmeyer flask, this big glass boat, and a ring stand to set up an ice bath. This reaction has to be, again, very carefully cooled because the subsequent steps are going to heat it up a lot, and heat will destroy our yield. So, I make a nice little ice bath. And I gotta admit, this is like the prettiest setup I've ever made. I love it so much. Yeah. Now that our absolutely sexy ice buff setup is chillin', we're gonna prepare the rest of our reagents. So we have about 8.2 milliliters of chloroform, and using a 10-to-1 ratio for this reaction, we're gonna be having 8 milliliters of chloroform coupled with 72 milliliters of acetone. So we pour out that amount of our Dollar Tree acetone, and that is pretty much it. On top of that, we're going to be using a base catalyst. So you can use potassium or sodium hydroxide. I've always seen it done with potassium, but I didn't have that, and I'm too broke to get it, so sodium hydroxide it is. Anywhere between 2 and 4 grams should be plenty. And now, with everything prepared, it's time to start our reaction. Yes, before you fucking ask, I sniffed the chloroform off camera, okay? You got me. And it smelled really odd, and the smell kind of lingered on my lab coat for like a week, and I was sleepy off and on every time I was working with it for like 2 days. It was hilarious. But yeah, don't do that. Be safe, kids. The 72 milliliters of acetone had already been added previously to our Erlenmeyer flask, and it was allowed to cool to around 3 or 4 degrees Celsius. Here I was just quickly adding the chloroform, and now I'm going to stick in a thermometer and let it sit and not do anything yet, make sure the temperature stabilizes. The reaction is going to start happening now, but very slowly. I just want to make sure it stays under like 8 degrees Celsius at the highest. So I'm just going to monitor that and watch that for a little bit before we move on. Now that our temperature has stabilized at like around 3 or 4 degrees Celsius, I'm like, you know what, it's not getting any colder than that, I'm just going to have at it, because I had to go like 2 hours after that. So I was kind of, planning around my busy schedule. So I just decided to start adding the sodium hydroxide. And I don't have it on camera. At first, I added it like a gram at a time, and I'd stir it, and I'd make sure nothing funky was happening. But after a certain point, the temperature wasn't changing at all. So I just added all of it. I started out with 2 grams, but the reaction didn't really seem to be progressing, so I added, I think, a total of 3.8 or 4 grams of our sodium hydroxide. And as you add it, at first it's going to kind of collect at the bottom, and it's going to look like it's not really doing much. But as long as you have strong stirring, you'll be able to see it break up into smaller particles and disperse throughout the solution. And it's not actually your clump getting broken up. What it is as the reaction happens, I'm not an organic chemist, so I might be explaining this wrong, but as the reaction happens, it breaks off and uses the hydroxide to attack like this acidic part on the chloroform, yada yada, weird organic weirdness happens, and the hydroxide gets regenerated. And it keeps doing that over and over again, and that's why you have these finely dispersed particles of sodium hydroxide in the solution. So yeah, I let that sit for a while, and it's looking pretty nice. After letting it go for about 2 hours, the temperature hadn't changed much, but it gained this kind of opaque color. So I decided to move on to the next step and pass it through a filter to remove as much of the sodium hydroxide as I could. I ended up not being able to remove very much, so I was kind of just like, whatever, it's fine. this should come out of solution in future steps and won't mess up our yield too much. Now we have probably the most dangerous part of this entire lab, which is getting our solution of acetone and chloroform and boiling it on a hot plate. So carcinogenic and highly flammable vapors are going to be going every which direction, so please do this outside or in a fume hood. I was like kind of scared the entire time I was doing this. But the reason why we're doing this is to concentrate our solution, since our chlorobutanol has dissolved kind of into our solution. Now, the opaque color is just our sodium hydroxide dispersed throughout our solution, but our chlorobutanol is actually dissolved in. There's also some excess chloroform we're trying to get rid of here, and it's just very important you do this. Plus, the actual heat, the high heat of boiling it, getting it to around 60 or 70 degrees Celsius, is imperative for the next stage, which is recrystallization of our chlorobutanol. So this is a very important step, but do it very safely. Oh my god, this gives me so much anxiety. This is so nerve-wracking to watch. Scary, boiling acetone. Alright, my antics aside, at this point you're probably done. Once you get to 20 or 30 milliliters left, you're good. What you're going to want to do now is get some ice cold water. I left mine in the fridge for about 20-30 minutes, and pour that into a large beaker. This is what you're going to use to recrystallize and crash out your chlorobutanol, because it's very insoluble in water, even more so insoluble in cold water. So that shock of going from super hot to super cold is the big part that's important here, because if you just pour it straight into water, it will come out, but it'll oil out. Niall Red talked about this quite a bit in his video. So hot acetone to cold water, very important here. After finally adding my boiling solution to the cold water, you can see stuff crashed out. Some of it immediately kind of oiled out, but you could definitely see some solid floating in there, and I was ecstatic. Crisis averted, I did it. Organic chemistry, chlorobutanol, yeah.
Holy cow. It works? Yeah, that's a weird smell. That's definitely not chloroform or acetone. It's not what we started with.
Oh yeah.
That's something else.
Super cool.
That's awesome.
Yeah. Thanks, Mr. B.
At this point, I took like a 15-minute break, and when I came back to my solution, I kind of had to go, so I quickly passed it through a filter, stored what I could, and went home for the weekend. I was ecstatic. I mean, I'd done it. Organic chemistry.
Oh my god, this is the weirdest smell ever. Got a very small amount of crystals at the bottom there.
When I came back into the lab a couple days later, I was really excited with how this went, but I was too lazy to recrystallize and try to get a bigger yield. That's kind of why I didn't go over stoichiometry or reaction mechanisms, just because everything was so dog shit. So if you want to see that, go watch Niall Red's video. I'll link it. It's late. I'm going to go to bed. Hope you guys liked the video. I just spent 3 hours editing. Yeah. It worked.
I did it, guys. Let's go.
Safety glasses off, motherfucker.
You know what it is. It's like a pregnant fucking